Hello, ladies and gentlemen. I am back. So, we're considering how to analyze electrical circuits. If we have a linear network and a sinusoidal forcing function, then the responses, the current, for example, in steady state, not when you flip the switch, but in steady state, the current response is going to be sinusoidal with the same frequency. Different phase angle, maybe, different amplitude, which is what this equation is expressing. And the trick is then to find the amplitude of the response and the phase angle compared to the original phase angle. Phase angle is 0 here, for example. So for this circuit, we can write down KVL, that as we go through the voltage drops, we have a positive voltage going this up here, and then a voltage drop and another voltage drop. The sum has to equal 0, rearranging it, which is the same thing as saying the voltage going through the source, like this, voltage change is the same as the voltage change going through the resistor and the inductor. We write down the form of the solution. This frequency will be the same as the frequency of this frequency, the frequency of the source. And given this trig identity, we can write down these constants here. And yes, and we can write it down here, what the derivative and what I has to be. And using trig identities, we're taking the sum angle formula and converting it to A1, A2. Before going much further, I just want to look at these identities for a second. So I of t is going to equal I gotta find my mouse cursor. There it is. There it is. So the current is going to equal to A, and expanding this trig identity, times cosine omega t plus, or times cosine phi minus sine omega t sine phi, and that this trig identity here is the cosine of omega t plus phi, which means that this A times cosine phi has to equal A1. Okay. A2, similarly, A2 has to be A times the sine of phi with the negative sign. Hold on to that. We're going to need it. And I need, or let's see, do I have another? Yeah, I have something else coming in, so I need to erase what I put up before. That's why I said hold on to it. Might need to back up the video. Plugging and chugging LD IDT, expanding it out, taking all this stuff plugging and chugging it into here and here, by the way, cosine omega t. There's the L's. Same thing with the R times I, R times the I, and putting it, collecting terms in terms of sine and cosine. RA2, RA1 has to equal the stuff on the right hand side. The coefficients of the sine, this stuff right here, has to sum to 0. And the coefficients of the cosine, this stuff right here, has to sum to Vm. We write this down, and now we have a linear algebra problem and can figure it out using standard linear algebra techniques. Solve two equations and two unknowns. You guys know how to do that. Moving on. Or before I move on to the next slide, all you need is algebra. Oh, actually, that's not quite true. You got to use your calculus and trig to get to this point, and then it becomes algebra. So this is what I meant, that we needed to hold on to those trig identities so we can say what A1 and A2 are equal. And I did that on the previous slide. I did this on the previous slide to show this identity. And so we can see from the sum of the sine squared and cosine squared equals 1. A1 squared plus A2 squared equals A squared. Therefore, boom, we get this equation. And by dividing the two, we can see that A2 over A1 is going to be negative tangent, or this equation here. So this is the conversion factors between angles and amplitudes. Let's see, A1 squared plus A2 squared, that'd be Vm squared. Vm comes out as a constant multiplier of everything. R squared plus omega squared L squared over this quantity squared. Anyway, big hairy formula. Might as well write it down just so you guys can see it. So A1 squared is Vm squared times R squared over R squared plus omega L squared. So that's squaring this, or is it A1? There it is. Squaring this first. And I need to enclose the denominator and square it. Add to that this stuff squared. So there's A1 squared, I just wrote that down. A2 squared is going to be Vm squared. And I forgot a big old parentheses right here. Open parentheses. Omega squared L squared over parentheses R squared plus omega L squared, the whole denominator squared. Okay, and so we can see the numerator has to equal R squared plus omega squared L squared, which will cancel out this. Here's R squared plus omega squared L squared here, and we finally derive this. It's pretty easy to see how to go from here to, this stuff here, to this equation. I'll leave the rest to you. The tangent, A2 over A1, and there it is, right there. Now, there's something that's bothering me. Right. you'll notice that they dropped the negative sign. You'll get the magnitude of the angle this way with this equation, but you won't know if it's lagging or leading. You need to think through that just a little bit. And I'm looking closely to say, if asked, did they drop the negative sign? A is always going to be a positive number. Well, we'd have to look at the previous cell to remember the equation for A2. Was A2 a negative? Okay, let's go back a bit. There we go. No, it wasn't. There. A2 was not a negative by itself, so they dropped a negative sign. Okay. Let's go. Ah, there's where the negative sign comes back. So they're trying to bamboozle us. That's okay. You guys are smart. You will catch things like this. Okay. This is for an RL circuit, by the way. This statement here about lagging the voltage is for an RL circuit. It's not for all circuits, by the way. L as a component will lag the voltage. If it's only L, if it's a pure inductive circuit, it'll be 90 degrees. Okay, I think I'm going to go ahead and stop the video right here.